Right now, you're breathing without thinking about it. Air goes in, air goes out, you never question it. But imagine standing on the red dust of another planet, your suit sealed tight, your gloved hand resting on your helmet's release latch. What if you just twisted it? What if you let Mars in? You'd assume you'd freeze instantly, or explode, or suffocate in seconds, gasping for air that isn't there. That's what the movies tell you. But the real answer is far stranger. Your body wouldn't explode. It wouldn't freeze solid either. What would actually happen is slower, quieter, and in some ways more disturbing than anything Hollywood ever showed you. Start with the basics. Mars has an atmosphere, but barely. Pressure on the surface is less than 1% of what you feel on Earth right now, sitting wherever you are. That number matters more than almost anything else in this story. Pressure is what keeps your blood liquid. Pull enough of it away, and you cross something scientists call the Armstrong limit, named after Harry Armstrong, a flight surgeon who studied what happens to the human body at extreme altitude. Above that limit, water boils at body temperature, not because it's hot, because there isn't enough pressure pushing back against it. So the moment you open that helmet, the saliva on your tongue would begin to boil, not burn, boil. The moisture in your eyes would start to do the same. It wouldn't be painful in the way fire is painful. It would just feel wrong, fast, and you'd know something catastrophic was happening to your body. Here's the part most people get wrong. Your skin wouldn't let you explode. It's strong enough, elastic enough, to hold your body together even as gases inside you tried to expand outward. Astronauts who have survived brief depressurization accidents in test chambers describe swelling, not rupture. Your body would puff up. Your skin would stretch. It would hurt, but you would not pop like a balloon. What would actually kill you first isn't your skin or your blood. It's your lungs. Mars's atmosphere is almost entirely carbon dioxide. Less than 0.1% of it is oxygen your body could use. The second you exhaled, you couldn't pull in another breath from your surroundings. There's nothing there for you. You'd have somewhere between 10 and 15 seconds of useful consciousness, the same window engineers measure inside vacuum chambers on Earth, before the lack of oxygen in your bloodstream put you under. 10 to 15 seconds. Think about how short that actually is. That's barely enough time to read this sentence aloud. And the cold, surprisingly, it wouldn't reach you fast enough to matter. Mars's air is so thin that it can't pull heat away from your body efficiently. There's almost nothing there to conduct it. You'd lose consciousness from lack of oxygen long before the cold became your problem. The temperature outside might be negative 80 degrees Fahrenheit, but your body wouldn't have time to notice. So picture it now all at once. The moisture in your eyes and mouth starting to boil, your skin swelling slightly, stretched but intact, your lungs grabbing for oxygen that simply isn't there, and within seconds, the world going dark, not from cold, not from explosion, but from your own blood running out of the one thing it needs most. If someone resealed your helmet and restored pressure within roughly 90 seconds, doctors believe you could likely survive, though with real injuries. Past that window, the chances fall sharply. Why does any of this matter to you, sitting safely on Earth right now? Because it tells you something most people never think about. You don't survive on this planet by accident. You survive because of a stack of conditions so specific, so narrow, that almost nowhere else in the solar system replicates them. Earth sits at just the right distance from the sun, close enough for liquid water, far enough to avoid being scorched. Scientists call this region the habitable zone, sometimes nicknamed the Goldilocks zone, not too hot, not too cold. Venus sits just inside its edge and became a furnace. Mars sits just outside it and became a near-vacuum desert. Earth also has a thick atmosphere, roughly 100 times denser than Mars's, held in place by gravity strong enough to keep it from drifting into space. And it has a magnetic field, generated by molten iron churning in its core, that deflects the worst of the sun's radiation before it ever reaches you. Mars lost most of its own magnetic field billions of years ago. Without it, solar wind slowly stripped away much of its atmosphere over time, according to data gathered by NASA's MAVEN mission. which has spent years measuring exactly how that thinning happened. You don't think about any of this when you step outside. You don't think about pressure or oxygen ratios or magnetic shielding. You just breathe. But every breath you take is a kind of inheritance. It was built by billions of years of geological and atmospheric history that happened to align in your favor on this one planet at this one moment. Carl Sagan once described Earth as a thin blue line of breathable air wrapped around a rock floating in the dark. He wasn't exaggerating for effect. He was describing a fact. The layer of atmosphere you depend on is impossibly thin compared to the size of the planet beneath it. If Earth were the size of an apple, its atmosphere would be thinner than the apple's skin. That thin skin is the only thing standing between you and the same 15 seconds an astronaut would have on Mars. Engineers who design spacesuits know this better than anyone. Every suit is essentially a personal, wearable Earth. It carries its own pressure, its own oxygen, its own temperature control, because nothing outside it can be trusted to keep you alive. Researchers studying suit failures at places like NASA's Johnson Space Center treat every seal, every valve, every latch as a life or death detail, because on Mars, there is no margin for a small mistake. So why does this matter to you, here, now, reading this with 2 working lungs and air pressure you never have to think about? Because the conditions that let you exist are not the default setting of the universe. They are the exception. Step outside that exception, even on a planet that looks almost familiar in photographs, with red soil and pale skies and small rocks scattered like any desert on Earth, and your body is given 15 seconds before it stops working the way you've always trusted it to. You don't need to fear Mars to understand this. You need to recognize what it reveals. Every ordinary breath you take today is happening inside a window of conditions so precise that scientists are still studying exactly how rare it might be. Every comfortable moment where you don't think about your lungs, your blood pressure, your skin holding everything together is a moment built on a planet that got almost everything right. You'll go back to your day in a few minutes. You'll breathe without noticing it, the same way you always have. But now you know what's actually holding you together. It was never guaranteed. It still isn't.